Hello students, so let us start with carboxylic acid part. Now first we will be seeing the introduction to carboxylic acid. Now the organic compounds which contains carboxyl functional group are known as carboxylic acids. Carboxylic acids can be of two types, aliphatic carboxylic acids or aromatic carboxylic acid, depending on whether your COOH group is attached to aliphatic alkyl chain or aromatic aryl group. Some higher members of aliphatic carboxylic acids containing 12 to 18 carbon atoms are known as fatty acids because they are obtained by the hydrolysis of fats. Now let us see the IUPAC nomenclature for carboxylic acids. According to IUPAC system, the name of the carboxylic acid is derived from the corresponding alkane by replacing the terminal E with oic and adding the word acid. For example, if you have HCOOH, which means your carboxylic acid contains only one carbon atom, so the corresponding alkane will be methane, and if you replace the terminal E of methane by oic acid, you get methanoic acid. Then comes CH3COOH. Since this carboxylic acid contains two carbon atoms, the corresponding alkane will be ethane. Now replacing the terminal E with oic acid, you get ethanoic acid. The common name of methanoic acid is formic acid and the common name of ethanoic acid is acetic acid. Similarly, you will get propanoic acid and butanoic acid. If your carboxylic acid is further substituted, then the following set of rules is to be applied to give IUPAC name to the compound. The first rule is select the longest chain containing carboxylic functional group. The second rule is the carbon chain is numbered from the carboxylic acid group, which means your carbon atom of carboxyl functional group is to be numbered 1. Third rule is the position of the other substituents is indicated by the number. For example, if you see the first compound, then this is the longest chain containing your carboxylic acid functional group, and it has been numbered in such a way that your COOH group gets the lowest locant, which is number 1. And as you can see, there is a bromo substituent present on your second carbon atom, and hence this compound becomes 2 bromo and total 4 carbon atoms, and hence butanoic acid. Now let's see the second example. See over here, once again this is the longest chain containing COOH group and it has been assigned the lowest locant, which is number 1, and there is a methyl group present on the second carbon atom, and thus this structure becomes 2-methyl butanoic acid. Okay. If your organic compound contains two carboxylic acid groups, one at each end of a hydrocarbon chain, then they are named as alkanedioic acids. For example, as you can see in the first structure, two COOH groups are directly linked with each other. Hence, total 2 carbon atoms are present and the name of the compound becomes ethanedioic acid. The common name of this compound is oxalic acid. The second structure shows that two COOH groups are connected via one CH2 group. Thus, total 3 carbon atoms are present and name of the compound becomes propanedioic acid. The common name of this compound is malonic acid. In the third structure, two COOH groups are linked via two CH2 groups. Hence, total 4 carbon atoms are present and the name of the compound becomes butanedioic acid. The common name of this compound is succinic acid. Similarly, you have pentanedioic acid and hexanedioic acid. and the common names of this compound is glutaric acid and adipic acid respectively. So with this, we are completing the introduction and IUPAC nomenclature of carboxylic acid, and in the next video we will be starting with the preparations of carboxylic acids.